morning. I thank KSUSA for giving me the opportunity to deliver this guest lecture. Statistics has been generally considered as dry, boring, complex, difficult subject, and we surgeons do not attempt to learn it. Why surgeons should be learning this medical statistics? This is the topic today. To answer it in a more simple way, we need statistics to make sense of data. I will give you an oversimplified example. I have collected pulse rates of 100 healthy normal volunteers, and I have put it in the form of a table like this. What sense does it make to you? Obviously, it doesn't make any sense. Whereas if I put it same data like table like this, then you get some idea how to interpret the pulse rate. If I give statistical terminology like mean, median, standard deviation of the pulse rate, then you get a better idea and you know what to expect in the next patient. And graphs are very easy and quicker to catch the idea. We need statistics to design our studies. The statistics will tell us what data we have to collect, how to analyze our data, and what inference we can draw out of this data. And the conclusions should be based on the data. If you don't know statistics, what happens? You will end up like this man. He's struggling to see over this wall. All he needs is a single ladder and he has plenty of them. Still he is struggling. We Indian surgeons do a lot of surgeries. We have plenty of clinical material. Still, we find it difficult to convert it into good papers. It is required in almost all the fields in healthcare, utilization or research allocation, quality improvement or developing a product or pricing it. Everywhere statistics is required, but my intention here now is to concentrate only on surgeon, why he needs it. We need statistics to correctly interpret the numbers we come across while studying the article or with discussion in the journal club. If you are a medical college faculty, you need it to teach your students how to or guide them during their dissertation and the conclusion of the dissertation or writing an article, all these things. If you are a peer reviewer, you need this knowledge to assess the quality of the paper, whether the conclusions drawn were correct based on the data, etc. So you need that knowledge. If you are a postgraduate student, to write a synopsis, design your dissertation topic, dissertation study, write dissertation, or convert it into a scientific paper or presenting in a conference. Everywhere you need statistics. You must have at least basic knowledge of the statistics. You must understand what is a normal distribution curve, what is null hypothesis, what is alternate hypothesis, or standard deviation. All these things you must be knowing. This helps you in correct understanding of the numbers and tables you come up with while reading journal, etc. And if you have enough knowledge, you can even do the statistical analysis of your studies on your own. There is nothing wrong in approaching statisticians, but if you approach them with a certain basic knowledge, you are definitely going to get a better output. Without that, whatever they give, you have to accept it. If you are in private, you may not get the statisticians easily, and to get their services, you may have to pay them, and you may not get timely responses. They may send back your data telling that this is required, that is required to change the form or further clarification, and you are sending system back and forth communication sometimes goes for months. All these things somehow you can manage, but what I am really bothered is the last one. This is dangerous. Sometimes we get a wrong analysis and we do not even know that it is wrong. This is what happens if you don't know the statistics properly. I can give you plenty of examples, but I have taken a few examples I have come across to a typical type of examples, I can say. So this is one of the papers presented in KSS Econ. Student has selected a gel to see whether it can heal the ulcer faster. He had designed a randomized control study. This is the data table he has got and gave it to statistician without knowing what to do with this. Since each patient had a pair of data, initial ulcer area, final ulcer area, the statistician applied t-test, paired t-test, and gave conclusion p-value less than 0.05, gel is effective. Where he went wrong, actually you may not know, or even his the student's mentor also didn't understand where he went wrong. Actually, what he should have done, he should have calculated decrease in the area of the ulcer for each patient by deducting final ulcer area from the initial ulcer area. So now we have got two sets of data, and uh, independent t-test should be applied for his data to find p-value. What statistician had done, he had totally ignored the control group. Now if you do that, you get p-value 0.25. The correct conclusion should be del X is not effective. Another mistake what we do is we just accept whatever written in the journal articles, we just read it and accept it. It may not be true. There may be flaws in that. For example, you take this article was published in Indian Journal of Surgery in 2019 April, and when we read that there were several flaws, we noted down, we did a critical analysis, and we wrote everything systematically. Item number 7 entirely deals with the flaws in the statistics. All these things I wrote and sent back to Indian Journal of Surgery, and our article of critical appraisal was published in a subsequent issue of IJS. Actually, critical analysis are better done in journal class, where a group of surgeons will be sitting together, including postgraduate students. It will be a great learning experience. I am thankful to Dr. Lakshman for taking me as a faculty in Sagar Aster group, where the journal club is held on a regular basis monthly. Usually, we select a randomized controlled trial, which is published recently and in a good journal. This is the article we have selected. This is published in 2019 in British Journal of Surgery. The moment we see British Journal of Surgery name, we think everything will be correct, and we don't even think about it. When we actually do analysis, there were several flaws in research methodology also into statistics. They had calculated wrong p-value. They were using constant confidence interval for categorical variables. Like this, conceptually also they were wrong. Let's look at this conclusion what they had given. This study found significantly lower hernia recurrence rate after closure of the defect, that is IPOM plus, compared to no closure, because they calculated p-value 0.047 using chi-square test. We calculated p-value using the same chi-square test and for the same data, and we found p-value 0.55. Now this conclusion is totally wrong, and we have to reverse the conclusion. There is no significant difference in the incidence of the recurrent rate between these two groups. We noted all the flaws, the problems they had in writing the article in research methodology or in the statistics, and we wrote a letter to the editor of British Journal of Surgery. They accepted our letter and published in a subsequent issue of DJs. I am a peer reviewer for Indian Journal of Surgery and many other journals, and I keep on getting articles for review. There I find flaws in the statistics in several parts. So I will quote some of the examples. In this example, the author has used chi-square test for this table 1, 0, 2. See, if you have got numbers as small as 0, 1, etc., you should not use chi-square test. It is invalid. What you have to do, you should use Fisher's exact text. In this article, the author is trying to compare the accuracy of radiological diagnosis and clinical diagnosis. Again, they have used the chi-square test. Again, wrong concept. Chi-square test is used to compare, not the accuracy. If you want to see the accuracy of the test, you should calculate sensitivity and specificity, not chi-square test. In this article, the author has grouped the patients into 3 groups, 1, 2, 3, depending on the level of HbA1c among the patients of diabetic foot ulcers. There are several flaws. This is one thing. Peripheral vascular disease, he has given this and p-value, and how he has interpreted this p-value, just check here. The presence of peripheral vascular disease did not significantly affect the rate of wound healing. This is wrong interference. The data is correct, calculation of the value is also correct, but interpretation is wrong here. What he should have interpreted, the number of patients with peripheral vascular disease is same. That means it did not differ significantly between these three groups. But what he commented, it did not affect the wound healing. This is because of lack of understanding of the concept. Here, chi-square test has been used to find the association between the two categorical variables. Actually, if you want to check the association, you must use correlation and not chi-square test. Here, the author has used to calculate the mean p-value. This is also a wrong concept. P-values, if you got one set of p-values, if you put as it is, don't try to calculate the average or mean of the p-values. This is important for the PGs. They write synopsis of their dissertation and send to RTO Sometimes it gets rejected. And this is one such example. This PG has written and it was rejected because there were several flaws in the methodology and sample size calculation. See, this comes back after 6 months. Now, imagine the tension or threat of the PG, what he should be feeling. He feels, and if he wants to change the topic, 6 months is lost. There was a survey in 1987 to know the awareness and knowledge of medical statistics among doctors. A survey form was sent to 250 doctors. It had 9 questions based on elementary statistical terms. Only 59% responded. This is the attitude, and the median score was only 2.4 out of 9. That is the level of knowledge the doctors had among on the medical statistics. So that was a old survey, but it has not changed much over decades. I conducted a similar survey recently using Google Form. This is the Google Form I used, and I sent this form to around 400 uh, surgeons, including faculty, consultants, and PG students, and that is the form I used. The responders included the faculty in the colleges, which now among the assistant professor to professor, and consultant surgeons, and also postgraduate students. Half of them were not bothered to read the journal articles regularly, and those who read the journal articles, only 5%, 5 to 6% of them, they understood the statistical concepts well. Rest of them said they understand a little, and rest of the thing they are going to live it. And they feel the statistics should be taught at both undergraduate and postgraduate level. And when we asked what is the level of knowledge of their teachers to guide them, about one-third of them were satisfied, the remaining two-thirds they were not sure. What they do when they come across a statistical problem? About 60% of them they approach a statistician, and the next popular thing they do is to approach Google Guru. This is awareness among our own KCSA members. They are all KCSA members, and only one-third of them they are aware that the information on research methodology and statistics they are available on our website kscasi.com. Others they are not aware, but half of them, a little more than half of them, they knew that the free online software applications are available for easy calculation of the various tests. About half of them had direct access to statisticians. Probably they are the college faculty, and they say statisticians are approachable. About two-thirds of them they responded. But when we asked what is their opinion on the final output, about one-third of them they are satisfied. Two-thirds of them they are not satisfied about the final outcome. They did not solve all their problems. They had a lot of problems, like so many they have written, starting from arrogance of the statistician, not getting timely response, and communication gap, etc. They had so many problems, and they suggested what the suggestion they gave to me is that statistics should be taught in undergraduate and postgraduate level, and it should be made a compulsory subject in the exams also. Regarding their opinion on the survey, about 64%, two-thirds of them, they felt that this is a good survey. It is addressing a valid problem. and two of them said that it is total waste of time. Those are the extremes we got. And this is the interest. About two-thirds are interested to take quiz on basic statistics. I think ASASI should do something to address this interest. After knowing the problem, what can we do about it? All we need is a right mindset. We should understand that the knowledge of statistics is a must for surgeon and we must try to learn it. Once we decide, there are so many ways to learn it and solve your problem. Visit asa.com. There is a tab here, research methodology workshop. Click on that. You get all this information. Before Corona, we used to go to various medical colleges and conduct workshops. About 7 workshops we conducted. After that, Corona intervened. Then we continue to do this online on Zoom platform. There are 2 sessions, session 1 and 2. Click on session 1. Second half of the session 1 is totally dedicated to medical statistics. The other parts concerns with other aspects of research methodology. Here, if you click on research methodology workshop, you can get links to PowerPoint presentations, video presentations we were using for our workshop. Everything is available. You can download any of them, use as it is or with modification to conduct similar workshops in your own institute. We have not exercised any copyright there. You can use it freely. ASCSI also has published a book on research methodology and evidence-based medicine. One chapter here is dedicated to medical statistics. You can also read about the other topics. I also have created my own website, lakshminh.in. One page is dedicated to medical statistics. Click here. These are the calculators I have created using Excel. You can calculate mean, median, standard deviation, confidence interval, or do t-test. All these things you can do here. Here the main book I mentioned just now. It is available for free download here also. And here we have given links to many useful calculators. You click here, you can do all these tests of significance, how to randomize using computer generated randomization, how to calculate the sample size. All these things you can do. And I also have written one book, Medical Statistics for Beginners. It was published in 2017 by Springer. If you are interested to buy it, it's available on Amazon. Another important thing is in research.net, there is a option to ask questions. Click here, in this box, type your question, and there is a group of good knowledgeable persons who are interested to help you out. They will answer your question, answer and solve your problem. That also you can do. In 21st century, not only you have to work hard, also you have to work smart. So this additional knowledge of statistics will go a long way in doing your research. To conclude, ladies and gentlemen, the knowledge of statistics is a must for all doctors, and that includes surgeons also. Statistics is required to make sense of data. It's high time that we learn statistics and teach our students also. It should be made a compulsory subject in undergraduate and postgraduate curriculum. Don't bother about the complexity of the calculations. You can do it easily with free software or paid software which are available on net. And only thing, you should have thorough understanding of the concept, what is to use where, how to interpret. This is more important than calculation part. Here my intention is not to tell you everything about statistics, but to create interest in you on statistics, to make you realize statistics is required. We have to learn. That is my intention. And thank you for patient hearing.